everyone. Now we are in chapter 6, alternating current. Before this we learned about the direct current. So what is the differences between the alternating current and direct current? What is actually alternating current? Let me explain the direct current first. When the circuit is connected to the battery or to the drive cell, the current will flow in one direction, from the positive terminal to the negative terminal through the resistor. The charge is always flowing in the same direction. The voltage across the resistor can be represented by VT graph. It has a constant voltage, so that we can conclude that the direct current, the current flow in only one direction and no changing in direction and magnitude. Alternating current is defined as an electric current whose magnitude and direction change periodically. We have a circuit connected to the AC source. So this is the AC source symbol. So the current now will flow from the positive terminal to the negative terminal. For the first half period, the current flow in clockwise. After a half a period, the direction of the current will flow in opposite direction. Means that the terminal also change. The current sweeping back and forth, so the charge flows in one direction, then the other direction, and back again. When an AC flows through a resistor, there will be a potential voltage, a potential difference of voltage across it, and this voltage is alternating and can be represented by VT graph. Starting from 0, it will increase to the maximum voltage and return to the 0 and changing the direction, increasing to the maximum voltage and drop again to the 0 in one complete cycle period. So we can conclude that alternating current, the current always change in magnitude and direction. This is the sinusoidal alternating current, and the equation for alternating current, I equal to I naught sine omega t. Omega is the angular frequency or angular velocity, and we can calculate the angular frequency by using equation omega equal to 2 pi f, and then f here stands for the frequency. What is the frequency? Frequency is defined as a number of complete cycles in 1 second, and the unit is hertz or per second. T is defined as a time taken for one complete cycle, and the unit of T is seconds. So how to calculate the period? T equal to 1 over F. I naught is defined as a magnitude of a maximum current, and the unit is ampere. For sinusoidal alternating voltage, we can use equation of V equal to V naught sine omega t, and then V naught here is the peak voltage that you can get from the graph. And then omega is the angular frequency, also using the same equation, omega equal to 2 pi f. As we know, the alternating current change sinusoidally. That's why we need the IRMS to represent the whole alternating current or alternating voltage. So what is meant by a root mean square current and root mean square voltage? Root mean square current is defined as the value of the steady direct current which produce the same power in a resistor as the mean or average power produced by the alternating current. So you can calculate the IRMS using the equation of IRMS equal to I naught divided by Z2. And then I naught here represent the peak current. You can get the value of the peak current from the IT graph or from the equation of the I equal to I naught sine omega t. And then take the value, substitute into the formula of the IRMS. For the root mean square voltage is defined as the value of the steady direct voltage which when applied across a resistor produce the same power as the mean or average power produced by the alternating voltage across the same resistor. And then we can use the equation of VRMS equal to V naught divided by Z2. The peak voltage also can get from the graph of the VT graph. And then from the equation of V equal to V naught sine omega t. Okay, for the peak voltage.